Okay, we have a look at question 9, which is a database question. Right, so this may be new to you. So maybe you can listen to how we approach database questions. Right, so database questions, they'll give you details, right, a lot of information, sometimes like that, right, and then you are expected to decipher the information while answering the questions. Okay, so anyway, back to this database question. Right, do note that database questions can be of varying difficulty, but in general, based on recent trends, the database questions have been quite manageable, right? So they are around 10 marks, right? Sometimes can be 11 or 12 marks depending on the year. But generally, out of these 10 to 12 marks, about 2 to 4 marks can be quite hard, all right? And so you don't have to be too worried if you cannot deal with 2 to 4 marks of the total data question, right? It's probably perfectly normal. Anyway, let's start the data question. Right, the marathon is a long distance race of 42 kilometers. Water on the skin of a marathon runner evaporates as you run. State the differences between evaporation and boiling. Right, so this is one of your learning objectives. All right, answer can be found on textbook page 202. All right, I just state any two. Right, so evaporation occurs at any temperature. Boiling occurs at one temperature, the boiling point. All right, so if you may mention that uh, the boiling point of water or the boiling point of the liquid, right? In this case, I would say the boiling occurs at one temperature, the boiling point of the liquid, right? Because the question didn't state two differences between evaporation and boiling of water, all right? So, however, if you mention water, I don't think it's a big deal, lah. This one shouldn't be a big issue, right? So again, second point, I use a generic statement. Evaporation happens at the surface of the liquid only, right? I didn't use water here, and boiling happens throughout the liquid. Right, so that will be 2 marks. Okay, so you can see this easy 2 marks. All right, so not all database questions are difficult. Now we have a look at the data itself. Right, you can see it can be quite scary to look at this data. Right, I'm not going to deny that this data is not easy to digest, right? Because there's so many things, right? Mass, time, average body temperature. So what you want to do is have a quick read through. All right, don't need to worry too much if you feel overwhelmed. All right, that's probably normal because there's really a lot of information in all these parts of reading. All right, so let's just attempt the question. All right, so I'm going to bring this answer sheet away first. While I have talked. So I'll talk about question part one. Calculate the mass of water lost by evaporation from the skin of the runner in an hour. All right, so mass of water lost by evaporation, all right, in 1 hour. So I'll look back to the table, right? Where do I have mass of water evaporated? Right, so I'm just checking, and I realized that, uh, right, so I don't have mass of water evaporated. So I think I have to calculate this, right? So mass of water lost by evaporation, I probably have to calculate. So I look again, I look for evaporation, and I realize that this is the only sentence with evaporation inside so far, right? Okay, other than this one lah, which is a percentage. So it's less useful in calculation, right? So average loss of energy lost in 1 hour by evaporation from the skin is this amount. All right, so what else do I need to calculate? Mass, right? If you look around at the numbers, you realize that there's specific capacity, right? There's latent heat of vaporization. All right, so you will guess that it probably have something to do with one of these two things, right? So if the loss of energy just from evaporation, and you look at the front part, evaporation occurs at any temperature. What does this mean? This means that it can happen while not at boiling point, right? So at the point of running, I'll just evaporate without hitting boiling point, right? And therefore, I will likely to just apply latent heat of vaporization water, right? So this is LV, right? So this is amount of energy loss, okay? So it will be Q equal to M times LV. And the other hint that you probably can use this is because of the kg behind, right? Remember, I'm looking for mass, right? So somehow the unit inside must have mass, right? So this is how I come out with this solution here, right? These 2 marks, I would say, is moderately difficult, right? It's not that the equation, producing the equation is hard. It's just finding the correct data to put, and then after finding the correct data, then decide on the correct equation, right? That part is a little bit hard, okay? So the calculation itself is quite simple, lah. Okay, you can do a calculation and something like 0.96 kg. Right, assume the runner only loses energy by evaporation from the skin. Calculate rise in temperature of his body in 1 hour. So we want to see how much energy he actually loses in 1 hour, right? So, or how much energy he actually produces in 1 hour, sorry. Right, so average production of thermal energy in 1 hour by runner is this, right? Then the average loss of energy by evaporation of the skin is this. So the leftover is 3.2 minus 2.3 lah. Right, so because this amount he produced, then lost by evaporation is this amount. What happens with the rest of the energy? Probably raises its temperature lah. So that's where probably your specific capacity comes about. Alright, so in this case it's a Q equal MC delta theta question. Alright, earlier we already said that the thermal energy increased by the body in 1 hour is this difference, right? Amount he produced minus the amount lost by evaporation, right? And this value here is your Q, right? So this is your Q value, right? So you substitute, make theta your subject, substitute the rest of the stuff inside, right? So mass of the man is given in the question, right? So somewhere here, okay? Right, so again, I would say this is, sorry, there's a Celsius, so please don't make this kind of careless mistakes in the exam, it's quite bad. Right, so you see that I also make occasionally these kind of mistakes, right? Degree is for angle, degree Celsius is for temperature. Okay, anyway, so this is the rise in temperature. We've calculated these 3 marks, right? Why 1 mark probably for this line, right? 2 marks standard for this type of calculation, right? Right, moving on to part 3. Okay, we'll carry on with part 3. So using your answer in B part 2, show that evaporation from the skin is not sufficient on its own to prevent overheating during the race. Right, so somehow I need to use this temperature to show that the person overheats, right, if only evaporation happens. So let's look at the data. Alright, so I'm looking for overheating, and yes, overheating is somewhere here. Right, so if I go above 40 degrees Celsius, I overheat. My starting temperature is 37. How much temperature did I gain? 3.67. So 3.67 plus 37 will give you 40.67. Right, so it's not current temperature after running, right, is 40.67, which is above the 40 degrees Celsius mark, which causes overheating, which may lead to serious damage, right? So this whole sentence is actually sort of lifted off this part, right? So I would say that the answer, of course, firstly, you have to calculate this value out, all right? But once you calculate this value out, then the answer is about stressing that this value is above the 40 degrees Celsius mark, which can cause serious damage. Right. Other mechanisms for evaporation occurs in breathing. Water is vaporized in the lung and then exhaled. Right. Assuming there is no increase in the runner's body temperature during the race, calculate the mass of water vapor the runner exhales during the whole race. Right. So whole is bold here. Right. So if something is bold, normally they're trying to hint to you something. Okay, pay more attention to this bold word. Alright, so anyway, there's no increase in the runner's body's temperature. This is the key part, right? What it means is that this temperature increase did not exist, which means that I need some way to deal with this 0.9 times 10 to the power 6 joule of thermal energy produced by the body, which is not dealt with via evaporation. Alright, so this amount of energy, right, 0.9 times 10 to the power 6, okay, must be then expelled through breathing. Okay, so how do I figure out how much mass of water vapor is exhaled? Right, I realized that in 1 hour, right, given that this is the amount of heat that I expel, right, the mass of water vaporized must be given by this formula, right, Q equal mLV. Again, this is a very common formula in your thermal properties. Okay, so you calculate this divided by this, alright, which your LV is again the same LV here, right, the same LV as this one. Okay, so you get mass as something to the degree of 0.375 kg, alright, but I hope you realize that this for 1 hour, okay, because if you realize all these values here, right, are actually for 1 hour. Okay, so 1 hour, right, that's the amount of energy that I produce that is not dealt with by evaporation. Okay, so in 3.5 hours, you just need to multiply by 3.5. Right, so that means this value divided multiply by 3.5 to get this value. Right, moving on. If the runner does not drink any water during the race, using our answers in B part 1 and part 4, determine level of dehydration of the runners at the end of the race. Right, so I need to find the total mass of water lost now, because dehydration, if you look at this column, right, is about percentage of body mass lost by evaporation of water. Right, so I just need to calculate how much mass of water is lost by the body. All right, and I do that by using parts B part 1 and part 4, right? So remember again that this is the end of the race, so this is the whole race. So B part 4, I already know the answer is, in the whole race, I lost 1.31 kg of water, and in B part 1, I lost 0.96 kg of water, but again, please be careful, this one is in 1 hour. Alright, so this one I need to multiply by 3.5. Right, so 0.96 kg times 3.5, right, so that I get water loss by evaporation throughout the whole race, and then I plus this one, right, which is water loss through the lungs, right, or breathing, okay, and that's how you get this value 4.67, right? So percentage of body mass lost, this easy, take this value divided by the runner's mass. You should get 6.7%, which according to your table over here is severe dehydration. All right. Okay, so what I would say is that the last few questions, I think this part, this value, if you do it slowly, I think you can get it. All right, but sometimes the question is, should you spend so much time at a point where you're not certain you get the marks or not? All right, my answer is I'm not sure that's the best thing to do lah. So if you look at this question, this case of database question, right, I would say that I'll do as much as I can. All right, I'll make sure that whatever I can calculate, I'll calculate out. If I get stuck, right, I would not bother to spend that much time to slow myself down. All right, in the data question. And later on, when you look at the questions behind, you'll see why. Right? It doesn't mean that here, from question 9 onwards, the questions are all 10 marks. Means that the questions are always harder. Sometimes the questions get easier. Right? So make sure you finish the paper, reach the back of the paper. Right? So sometimes after you finish the rest of the paper, then you come back here, you're more relaxed because you know that I more or less finished the paper, I still have spare time. Then I can take a little bit more time to think about how to do this part. Right? And that's how you get your answer.